This is Roger Boland from the Container Graphics Corporation in Pineville. This is going to be a video on calibrating the SDS machines. Easy business. To do your calibrations on length and your arcs or your bends, two tools you're going to need a micrometer. Digital is best, but any micrometer will work, and also a protractor. This particular protractor, as you can see, I added a piece of 1/2 inch 4-point score just to extend the length, because the greater the arc, the longer it's going to be. And this bit right here, the small length, will sometimes not measure. The greater, the wider radiuses that you'll be calibrating. So if you have that on hand, it's going to add a bit of a straight edge, give you some extra length so you can get a more accurate reading from your protractor. What you want to do before you do a full calibration is make sure that your length is calibrated and your bends are calibrated. If those are off, the full calibration is going to be off as well. I'll show you how to do that. Okay, if you don't already have a file made for length, to a certain length to test, then how you do that from scratch is you open up your window. The first thing you do is you click your square icon. It tells the computer what to draw. And then you have coordinate lines up here that you're going to enter in. So your first coordinate is going to be just 0, 0, and the greater sign. And then hit enter. The next coordinates you're going to put in are going to give you your length that you're going to want to actually run the piece, so you have something to calibrate with your micrometer. So in this case, I'm going to do 25.4, start with that. That's an inch in millimeters. Hit comma, and then the next number is going to be the length you want to calibrate. So if you're doing on the curved machine, you can do longer distances because you're going to be using the board to measure that. On the straight machine, you'll use a micrometer. It's a little bit more, unless you have a really big one, but it's a little bit more restricted in its length. So in this case, I'm just going to do 100 millimeters. I know that length is actually available on the micrometer. And then once you put those two coordinates in, you end it with another greater sign and then hit enter. And then the next one is just going to be 0, greater sign, then enter. And now you can see you have a box that comes up here. Once you have your box drawn, you can see one side is 25.4 as I put in, and the next side is 100. This is the side you're going to want, so what you do is you just draw a line, pick that side. You need one, don't add any length, and then you run it. Once you've done that, you want to go here to your file, save the fill file for this, and you can name it whatever you want. I've already got one named, and I just named it length test and what the length was. So in this case, it's going to be 100, so you can put length test 100, and whatever, or whichever, however you want to remember it. But create the fill file, and once that happens, next time you pull the fill file up, you only have this line, and you can just run it again. Right. Once your piece is ran, use your micrometer, and you measure it. It's pretty simple. And that length is supposed to be 100, and you're sitting at 99.92 right now. Now that's not bad, but you can adjust that, and I'll show you how to adjust that. Measurement from your micrometer. Come up here to the configurations icon and open it up. If these are not highlighted, then go to parameter 2, type in your password, which is typically SDS, hit enter. Go back to parameter 1 and you'll see that these are now highlighted. And in this box here, calibration pulse, this top box tells the computer what the length should have been, and this bottom box tells the computer what it spit out. So in this case, we tell the computer it should have been 100, hit enter, And in this window, I'm going to tell it what it was, which was 99.92. Hit enter, and then apply. Okay. And then run another piece. Check your calibrations. Now, as you can see, I've got two pieces now. This was the first one in my hand. After I told the computer what it gave me, 99.9192. This is the second piece after I entered the information. We're now sitting at 99.98. Right at 100. Within 0.98, 100.1, or 100.01, 100.02. Those are all very close. Those are good numbers to keep in mind with. And if that's what you're spitting out, it's fine. It also doesn't hurt to run multiple links, or 10 in a row, or 20 in a row, even if you have time, and make sure and check all those, and maybe get an average to make sure that every piece is running the length, in this case 100 millimeters, as you're supposed to be. Once it's doing that, your length is set, and then you can move on to your C test or your bend test. Alright, once you've got your length test done, you want to test your bend. I again already have a file made. If you do not, you make a file similar to how you make a length file. The rectangle icon, start your coordinates 0, 0, greater sign, hit enter. And then in this case, instead of doing a shorter side and a longer side, you want all sides to be the same. So we're just going to use an inch, which is 25.4, and then we'll hit a comma, 25.4 again, greater sign, and then enter, and then 0, comma sign, or greater sign, enter, and now you have an inch by inch square here. And you'll want to pick just 3 sides. So again, no length added, and then run that. So we ran our piece. Now we take our micrometer again, and we're going to butt up one side to the flat side. And the important here is not that we put in 25.4, but it's rated to 26.5. That's taking into account the width of the rule. What you're looking for is to make sure that 26 point, whatever that number is within 0.2 of the other side. So here you've got 26.33, and on this side you had 26.49. It's a fraction of a millimeter, but that's that length, and then you can also tell it's even. You want these two lengths to be even. You also will look at it, and it will also tell you if your bends are at right angles or 90 degrees or not, which is something that will be taken care of when you do the full calibration. This here is pretty close, but we're still going to do some calibrating. If your links are different on either side, that tells you that your bends are off. They're going to be missed, and every time you run a piece, they're not going to hit their mark. So to adjust them, again, you go to your configurations icon, and here at the nozzle guide, left and right, and then once again, if these aren't highlighted, go to parameter 2, add in the password, SDS, hit enter, then go back to parameter 1. But what you're going to do is you're going to adjust these two numbers here, and they match. So when you do this, depending on which side was short, if it's the left side, then you want to increase it on the left, increase the number, and if it's the right side, you want to decrease. But you don't want to decrease it by a whole lot. You don't want to adjust this number, you want to adjust the decimal side. So here I've got 250.77. If my pieces were off and needed alignment, I would adjust it by no more than increments of like 0.05. So in this case, I'm gonna if it was long, I would come down. So I'll change that to a 2. It was 7, so 250.72. Hit enter, and then highlight the next one, 250.72. Enter, and then run the piece again. until you see that the lengths are becoming equal with each other. And again, hit apply. I have here a piece of curve rule that I've done the same thing that I just did with the straight. This is the straight rule, this is the curve rule. Now I bring this up because you have an arc with the curve rule that you have to factor in. With the straight rule, it's easier to get your measurements because you can just make sure you're flush up against one side and close it down. Here, the length from these 2 points here are not going to be the same from these 2 points here. So what I suggest to you to do when you're calibrating your curve rule is to find the straightest point that you can go from. In this case, I always use the bevel, the bottom of the bevel here, which is, it's not straight, but it's pretty straight. And I'll use that as my marker. And I'll line up one side and I close it down. Try to keep it as still as possible, and then that allows you to do it the same side because you're using the same point of reference to get an accurate measurement on this. Again, use your bevel, that's your straightest point on here, on either side to get an accurate length from your left and your right. And the way you would adjust is the same on either machine. It's either on the straight machine and the curved machine. How you do your calibrations in the program is the same as a curved machine. It's just one has straight rule, one has curve rule. Now that you've got your length test calibrated and you've done a bend test or a C test and that's calibrated, you can do a full calibration on the machine. Now, one thing I want to note is if you have different parameters see here we have 1030 on the D setting, 990 on the C setting, and then 937 on the A setting. Each calibration you do, you need to make sure you're under whatever setting and whatever rule you're running through the machine. In this case, we're running 1030, so I'm on the D setting. I'm going to apply that. Once you have your setting applied, you go to settings up here in the toolbar, click on teach, and it'll bring up this window. It's important to note that whatever calibrations you do now, once you're on a certain setting in your configurations icon or window, it's only going to apply to that window. So whatever I do here is going to be on with the 1030 setting, and it's not going to affect